I'll get set up with a coordinate system here, and we'll just look at a number of different features of this plot. So first of all, I want to point out that the domain is negative infinity to 0, union 0 to infinity. Notice that at 0, the 1 over x causes division by 0. We have a vertical asymptote there. Okay, I want to note regarding symmetry that this function f of x is an odd function, and so it's symmetric about the origin. So let me note that down. And we had a tutorial way at the beginning on a review of characteristics of functions, and there we looked at what it meant for a function to be odd, that the function is symmetric about the origin. So once we plot sort of 1/2 of the graph, we can then sort of reflect it about the origin and get the other portion of the graph. Technically, it's not reflecting it about the origin, it's just symmetry about the origin, and we'll look at how that looks here. Okay, next, why don't we look for, we could look for intercepts. And for x-intercepts, we would be setting y equal to 0 and trying to solve for x. And this is impossible, so there are no x-intercepts. Okay, let's look for y-intercepts. For y-intercepts, we would look at f of 0. F of 0 is not defined due to division by 0, so there's no y-intercept. Okay, next, why don't we look for critical points? So investigating critical points, we'll compute f prime of x, which is 1 minus 1 over x squared, set it to 0, we'll get x equals plus or minus 1. And so let's set up a scale here, maybe that's -1 and +1, and we have critical points at those locations, but we need to know how high or low the points are. And let me also make my location of +1 look symmetric with my location for -1. Okay, so we want to know how high or low f of 1 and f of -1 are. F of 1 is 1 plus 1 over 1, which is 2. F of -1 is -1 plus 1 over -1, which is -2. So now I'll set up a scale on the y-axis. So maybe something like that. Again, the scales on the x and y axes can be different. We just have to be consistent within each scale. So f of 1 is 2, and f of -1 is -2. And you can see the symmetry about the origin. Okay, and we have horizontal tangents at those points, so I'm going to indicate that for myself. Now let's look at where this function is increasing or decreasing. So I'm going to look at a sign chart for f prime. The critical values are 1 and -1, and also 0 because the second derivative is undefined there. Okay, and so I'm going to do a test point in each of these 4 intervals that we have. So further negative than -1, f prime, for instance, at -2 will be positive, f prime 0 at -1. Between -1 and 0, for instance at -0.5, let's say, f prime will be negative. At 0 we have the vertical asymptote. Between 0 and 1 we'll get negative slope again, and past 1 we'll get positive slope again. Okay, and so really roughly speaking, as we pass through x equals -1, we're going from positive to negative slope, and as we pass through x equals +1, we're going from negative to positive slope, so something like that. We also know that we are approaching this vertical asymptote, so I can draw something in like this, and something in like this. Okay, now let's look for a moment at the second derivative. F double prime is the derivative of the first derivative, and we'll get 2 over x squared, which is always positive. I'm sorry, it's not a 2 over x squared. It's a 2 over x cubed, which is not always positive. Drawing a little sign chart for f double prime. F double prime is undefined at 0, and then f double prime is positive for positive x and negative for negative x, which is why we're seeing a concave down picture on the left and a concave up picture on the right. Now there's one more thing to look at here. I want to point out that there's a slant asymptote here. As x heads towards infinity, let's just look at what happens here as x heads towards infinity. So as x heads towards infinity, 1 over x heads towards 0, and so essentially f of x heads towards y equals x. So let me write that down sort of in words. So as x heads towards infinity, f of x, I'm just going to informally say that f of x looks like y equals x. And so here is a picture of y equals x, and our function heads towards y equals x as x heads towards infinity, and actually also as x heads towards negative infinity. And so when I draw this graph, I'm going to make this portion over here and this portion back here head towards the slant asymptote. And if you do have a graphing calculator, try graphing this function and you'll see that our picture here is very good. So that concludes this example.